So, very welcome to this fire chat with over champions of the SAS Hackathons. I am Einar, and together with Peter and also Christina, we are the SAS Hackathon office. And those that you see here in the blue hoodie, they are the champions of the SAS Hackathon that happened in the fall. And just before Christmas, they were awarded the industry or the technology or the speciality that they did win. And they are here at the SAS Innovate to be able to share that great experience. And they are nominated to the overall Grand Champion. So we are talking about this 1 month SAS Hackathon. The 1 month SAS Hackathon happens once a year, and it is a very different hackathon, right? When you normally think about a hackathon, you think a couple of days and physically together, but the SAS Hackathon is 1 month. It is all digital, and it is access to a learning portal for purpose and a SAS mentor. During that 1 month, the teams had access to SAS Viya. I see that somebody had challenged with the sound. Does it work? Yeah, perfect. During this 1 month, the teams had access to Viya with the latest technology. And again, this program is sponsored by Intel and Microsoft. And of course, Intel is in the room, so thank you, Intel, for being the sponsor. And of course, Microsoft, that is probably joining us in a few minutes. During this 1 month, the team is then tackled or are tackling challenges of their business or a humanitarian challenge. And after 1 month, they are then delivering back to the jury a 3 minutes pitch video and a 10 minutes pitch video that is telling how they have solved that challenge. What challenge? How did they use the tools? And that in storytelling. So in this little brochure that you all got, you will be able to see all their cases and their contribution. And those that are here, those that are one that had won a trophy by industry or technology or speciality. So today we will hear, and they will come up and they will get a diploma for their fantastic achievement. And on Friday, on the main stage, we will have one overall winner that will come up and grab the orange jacket. Like the golf sport of the Masters, or the green jacket, the SAS Hackathon has this convetted jacket. This is the jacket that you all are fighting for, right? But you are already winner. You are winner by the champion that you have already won, and everybody is the winner in the SAS Hackathon. Last year, we had 1,700 individuals that applied to come into the SAS Hackathon. They came from 71 different countries, and we onboarded 145 teams, and they were represented by 200 different organizations. After this 1 month, 72% completed. 72% in a 1 month hackathon. We had teams that were a brand, a customer. We had teams from a business partner. We had teams from students joining the hackathon of a customer or partner, or a pure student team. So there's a good mix of multidisciplinary setup. And the achievement is fantastic. This is inspirational. And again, you have access to all of them here in the QR code. Christina, Peter, and me, we were not alone. We had mentors and we had ambassadors sharing these stories, and the way that you have shared this on social media and how the media has picked this up is amazing. So first, let's give yourself a big hand of applause for being a champion and coming all the way to SAS Innovate to share this. 5 of you are coming from Asia, 5 of you are coming from Europe, and the other 5 is coming from here in the Americas, which is a fantastic travel to come and join this with us. All right, Peter, we are going to go through all those champions and invite them up one by one. and I will say, how do you want to play that?
So let's begin to celebrate the first team and recognize the first team. So I will call out Team AbuSearch from UK. Give them a big applause. First of all, congratulations to your win in the Data for Good category.
Thank you very much.
And then two questions. What was your problem statement and how did you solve it?
Well, the source of our use case was a chance meeting actually at SAS Innovate in London last year when we were introduced to representatives of the Child Rescue Coalition and the UK Metropolitan Police. The Child Rescue Coalition aggregates a huge set of data drawn from the online activities of child sexual abusers from sources such as public forums, from the dark web, from P2P, etc. That data set is then provided free of charge to law enforcement agencies around the world, including the Metropolitan Police. The Met were looking for support to help turn that data into actionable information that meant that officers would be able to arrest, charge and convict abusers. And that was where we at Catalyze Data came in, and that was really the genesis of Team AbuSearch.
Oh, fantastic use case and a very data for good use case. And
absolutely, yes, very much so.
And how did you solve it?
We loaded the data set into SAS Viya. We then used Python and natural language processing to extract key information from the data set, such as the original uploaders of abuse images, the connections that they have with others in their networks, and the communications that they were having with potential victims that they were potentially looking to groom and abuse. Through these and other techniques, we were able to demonstrate that it was possible to extract insight on a near real-time basis and provide that to police officers who were able to catch the abusers and prevent further abuse of children. And we were delighted to have the chance to work on this use case with our partners, the Child Rescue Coalition and the Metropolitan Police, and Team AbuSearch felt really pleased to make a contribution to this really important topic.
Thank you very much, and again, congratulations. A big applause to AbuSearch.
And if you open your folder and go into the public sector, you will see the AbuSearch there, and the QR code will take you to their 3 minutes and their 10 minutes use case and describe again the challenge that we just heard about.
Okay, next team out is Team Avalanche from Turkey. Big applause and welcome up on stage. I give you the mic now. Welcome, team.
Welcome. Yeah, thank you.
And congratulations on your win in computer vision. So tell me about your use case and problem statement.
Actually, our use case is about prevent a harmful station on the social media. What's influenced the people who get stressed and create a dangerous station. So we use the natural language processing for about that, economic forecasting, computer vision, and network analysis. So we get the data from the Twitter and also social media, and we understand is it have a big problem or not, and we make a report about that, and we give the NGOs or the relative authorities for prevent this action.
And how did you solve it?
How did you solve it? Would you like the technical part?
We solve it that we usually use SaaS tools like Google models and model management for NLP and forecasting. In the computer vision, we just fine-tune the YOLO models. After that, get those data, those data. We want to visualize and show that this data. For that, we use SAS ESP. and after that we solve that problem like that.
Thank you very much, and again, a great use. Congratulations on your win, and a big applause for Team Avalanche Turkey.
And again, in the folder, in the public sector, you will see that the winner of the Computer Vision Avalanche is there. Congratulations.
Next out is another team from UK, and we have Team Butterflies. Welcome up on stage. And before I hand over the diploma, you were a Grand Hack Slam winner, Models, Channel Readiness, Trustworthy AI, and the EMEA region winner. Congrats on that. And tell me more about your problem statement and use case.
Yes, so our problem was inspired by the fact that there were quite a lot of important events happening in the UK and worldwide. So there were quite a few natural disasters, there were elections in the UK as well and other countries as well. And one major problem that we face nowadays is the proliferation of misinformation, disinformation on public channels to influence the outcome of such events. And this is quite a big issue because it may lead to unfortunate accidents happening. And we want to prevent this and stop information from spreading and educate people about the facts that are defining what is happening.
Very, very valuable case. And how did you solve it?
So our solution was two-part. We had a classical machine learning model, which we created using SAS Model Manager and the data lineage tools, and that model was used to predict whether news was fake or not fake, as well as provide a probability of how confident it was about that prediction. And the second part was a generative AI element, which focused on providing an explanation for that model result so that it's easier to explain why certain news is fake and why and educate people on that.
Oh, thank you. Again, congratulations on your wins. Team Butterfly.
And even that one is found under the public sector, Butterfly, and the QR code.
And next out is a team that were winners of the energy case. So we have climate change and challenges to nuclear plant safety. IAEA, welcome up. And this is an interesting, it's a combination, it's a US-based team and a team from Italy. Yeah? Congratulations, and I hand over the mic first. Tell me more about your use cases.
So as everybody knows, there's a lot of extreme weather events that happen throughout the world. And so the problem challenge is to figure out how to safeguard important assets like nuclear power plants, right? And so we worked with IAEA in the Switzerland office, and the data was provided by PDC, Pacific Disaster Center. So they collect extreme event, weather event data throughout the world. And so the challenge was to figure out what installations could be at risk based on extreme weather events. And so we poured through a lot of data and then kind of tried to come up with correlations, divided the entire world in different regions, and then looked at extreme events, weather events in each of the regions. And then we did what is called typically a survival analysis kind of modeling. And then we come up with some risk assessments for each of these installations. And so the overall project was to kind of look at historical data and then come up with some risk associations for these important assets, and then provide recommendations as to what could be done, how to mitigate some of their risks. And so, for example, if there is heavy rain or thunderstorms in one particular region, hundreds of miles away, nobody cares. They didn't even know that such an event happened because, but then there's rivers that are flowing through the region, and so 2 days or 3 days afterwards, all of a sudden there is some big flooding that's happening, right? And so people get caught off guard, not knowing how to respond to these extreme events. And so the whole idea behind this project was to take a look at the extreme events throughout the world and then try to come up with some ratings. Oh, this is a very, very flood-prone region, or so try to come up with some risk assessments for different parts of the world. So that's the whole project.
Thank you. Very interesting project. And again, congratulations and a big applause. Thank you.
And the EIAI case is found under energy. Under energy.
And next out, we have the winner of forecasting. We have Data Curate from India.
Well, doesn't look like they are showing up. They are maybe doing some other activities right now. But Data Curate, if they come in, we will call them up.
Yep.
Data Curate.
Data Curate. And we check for another team, and this is the winner of the People's Choice. EY for a Better World. Do we have that team here? EY? And we save the diploma for later. Third time, maybe this team will be here, hopefully. We have another People's Choice, and this team comes from Indonesia. Imposter. Do we have Imposter here? Let's check again. New Peak Neurons. Are they here? No. Banking. Do we have the banking team here? Raffles Vietnam. Welcome up on stage. There you go. Congratulations.
Hi, thank you.
Congratulations.
Yeah, thank you.
Yeah. And tell me about your problem statement and use case.
So we have been seeing banking. In banking, there's a lot of policy and document, and that's why the place where a lot of complexity, uncertainty, and gaps amongst policy, and it's create a lot of problem for banks to launching new products, implementing decision engine. So we have been built a RAGI, a generative AI-based solution to overcome those challenges, and then it helps bank to read the policy document automatically, and then it extract from those policy document into data fields and business rule. And then our solution is also fully integrated with SaaS Viya. And then so you see from the policy automatically transfer into SaaS ID without any human interface. Or then it can reduce time for launching new product from months to weeks. And it's also reduced a lot of effort for BA and software engineer and tester also. So it's basically use Gen AI technique and our IP data model to build up those challenges. Okay.
Fantastic. Saving time and resources.
Yeah.
Have you put this model into production or are you using it?
It's now in production and it's licensed already.
It's okay.
It's a license already. Okay.
Fantastic.
Okay.
A big,
it's fully integrated with SaaS Viya. Okay.
a big applause for the banking team.
And the banking you find on the second page of banking. Raffles Vietnam.
And now it's time for Life Sciences. And we have a team from Italy, Team Ratio. Welcome up on stage. Big applause.
Thank you, everyone.
Yeah. And you know the procedure? Your
Yeah.
problem statement?
Problem statement.
Yeah.
So our idea was to try to find a way to streamline the process of bibliographic research for biomedical studies to help doctors, researchers, and students alike to find a way to retrieve articles faster. Because we know from also personal experience, as many of our colleagues have relatives or friends that are students or maybe doctors, and they know how much time it takes for them to research for documentation. So how we achieved that was through AI. In SAS Viya, we used an LLM to transform natural language queries. So you just need to write in any language, just like you would to talk to a colleague. And then through the LLM, we transform the query into a structured PubMed request to then retrieve articles, summarize them using SAS Visual Text Analytics, and we then rank them using Python, and everything is embedded into the SAS Viya platform, which was amazing, as it was really easy to handle both the back end and the front end. So yeah, that's it. I believe we were able to do that.
Thank you. And another case with the LLMs and AI.
Yeah, very hot topic.
Making it easier for everyone. Yeah.
Absolutely. Yeah. Also, no, because timing maybe in the healthcare sector is very important. If you can make anything faster, it's going to be better for everyone.
Yeah, absolutely. And big applause to the Ratio team.
Thank you.
Congrats.
The Ratio team you will find under Healthcare and Life Science, the Mineral Life Science. Oh, sure.
Then we have a team from US, and I have sometimes a difficult to pronounce this name, but I think I will get it right. I hope I will get it right. It's the statisticians, yes, from US. And this is actually another Grand Slam winner of 3 categories. An amazing use case. Tell us more about what did you do?
Okay. Thanks to Ina and Peter, Christine, the champions of all the champions here. And our use case is a heat stroke, which is a serious condition caused by high body temperature and high heart rate, leading to organ failure, long-term health conditions, and even death if unchecked. In 2020, for example, we have global death cases related to heat stroke for more than 4,200. And most of these cases happen in construction industry. Even a mild heat stroke case can cost employers and insurers more than $80,000 on average. So our focus is to protect over 200 million worldwide construction workers who are exposed to extreme heat due to climate change. And clearly, there's a critical need for this proactive intelligent system for predicting heat strain ahead of time and to minimize human toll, financial burden of construction companies and insurers. As to how we solve it, we founded a team of 6 experts from different areas. We are data scientists, AI engineer, medical doctor, and also system architect. And we partner with an IoT startup company called Be Inventor with presence in multiple countries in Asia. We integrate their smart helmet with sensors that stream live minute data, such as heart rate, skin, and ambient temperature, into SAS Viya Visual Analytics dashboard. In the middleware, we built in SAS Via Enterprise some engineered time series features and create some realistic synthetic data using SAS Data Maker. And lastly, calculate a physiological strain index. Using SAS Via's auto machine learning, we built models using 500,000 instances from over 300 construction workers and found that gradient boosting models consistently outperform other models. So now we are very confident that our models can predict high-risk heat stress case 20 minutes in advance, and we can explain our AI models globally through factor importance as well as locally, case-by-case basis. In the future, we are going to pilot test our model by deploying into devices in the smart helmets. Yeah, thank you.
Yeah, thank you. That's a fantastic cake. And they are the winner of Insurance, IoT, and the American region. Congratulations, great job.
And in the brochure, you find them under Insurance.
So let us check if we have another team from US, Supply Chain Resource Cooperative from NCCSU. Thank you. Congratulations. And yeah, you can take. I can hold it.
Yeah, sure. So about our problem, we wanted to build a system that support transparent supply chain, and more specifically about apparel industry. So the way that we handled that, we wanted to use data for good. So we collected a lot of audits from different manufacturing companies, mostly focused in apparel industry, and used SAS Via and SAS text analytics tool to run sentiment analysis, and later use the technique in machine learning called IRT, item response theory, to score different apparel industries or manufacturer and have a better understanding of those manufacturing companies who support fair labor and fair labor practices, and having a better understanding of those companies who support apparel supply chain in the world. That's it.
Thank you. And combining retail with data for good, that's a fantastic use case. Yeah. Congrats on your win. Big applause.
And NCSU you will find under Retail, Consumer Goods and Manufacturing.
And then we have another orange team from the Netherlands. Team Only Planet. And they were the winner of Public Sector. Congratulations. I will hold this for now and tell me more about your use case.
Yeah, so our SAS Hackathon Challenge focused on addressing climate resilience in the Green Metropole region in the Netherlands. And the inspiration for our case was the book by Tim van Hattem. He's an environmental researcher in the Netherlands. And he, in his book, he outlines 7 nature-based strategies to combat climate change. And so we brought together a group of experts, including ecologists, architects, engineers, and data scientists like me. I'm from Nodalize. And together we created an overview of the strategies in the book, solutions to climate change, and to ultimately create awareness. How did we do that? Yeah. We created a dashboard, and we used SAS Via and ArcGIS. We combined those technologies, and we integrated several sources of geographic data. And using that, we visualized several climate scenarios 50 years from now and even 100 years from now. And using that dashboard, we tried to create a shared platform for data-driven decision-making. And ultimately, this project actually laid the groundwork for future cross-border collaboration in climate resilience.
Fantastic. Congratulations on your win. And again, public sector combined with sustainability. Fantastic. Yeah.
Yeah, public sector is where you find the Team Only Planet.
And then we also have a student category, of course. And we have another team from UK, and that's the Data Ninjas. Welcome up and congratulations. And you know the procedure? Tell me more about your use case.
Oh, thank you very much for this opportunity, and thank you, everyone. Our use case in this situation was to identify and mitigate bias in historical admission data. And this was very striking because it was an issue that was really disturbing in most admission processes as long as machine learning is AI is concerned. So we were tasked with building a model that would predict, not just predict accurately, but predict ethically. And you see, we used iLink University as a case study where we had historical data to analyze, and we found striking, disturbing instances, because the patterns that we found there were actually disturbing because there were bias in the system. You see, most deserving students were not being admitted, not because they did not deserve it, but because of bias that was already baked into the historical data that was used to train these AI models. And our goal there was to uncover that bias and mitigate it. This was very important because it undermined the need for building an equity society, which is very, very at the core of even the UN Charter. It's promoting that, building an AI system that would promote equity and fairness in the community. So that was the challenge that my team and that was the world that we were set out to change. And thank God that SAS gave us that platform, that tool to use to mitigate that. So, and for how we went about doing that, yeah, like I said, I appreciate SAS again for the tool and the platform. You know, it gave us a change in mindset that it's not just about building models, but building models that are both performing well and performing ethically. You know, what we did was we initially built a predictive model. We use algorithms such as logistic regression. We use forest model, neural networks. We built all perfect, interesting models, good performance. But you see, that was not all we wanted. We wanted to build, like I said, a fair society, a fair admission process that everyone has equal chance and not based on their ethnicity or identity. So we had to use the SAS via bias assessment tool that helped us to, dug deeper and found some striking, disturbing thing that we talked about. We saw the performance bias. We were able to also investigate the prediction bias, and we found out that the white folks in that school, the white students, were having 75% true positive rate. And whereas the other, like the Asian group, were having 0% admission rate, and this was very disturbing. This wasn't a fair system that we were looking at. So even the legacy admission was also gaining 50% chances of being admitted compared to the non-legacy students. And this was very disturbing. This wasn't a model that we needed to build. So we saw that this was not just about fine-tuning the model. We had to rebuild the model all around and remove some of those disturbing variables, those variables that portray the bias, and we ejected them from the system. And this helped us to build an equity system that promotes responsible and trustworthy AI. The result was actually outstanding because those that were struggling to get admitted before the admission, like the white folks, dropped from 70 to 30%, whereas the Asians rose from 10% to 45%. And this was an outstanding and amazing result that we did there.
Fantastic.
Thank you very much.
Yeah, trustworthy AI, making great work. So congratulations, Data Ninjas.
And those you find in the students. So big hand for all the teams, of course. The photographer is here, so take your diplomas and all of you up on stage and we will make some photos. And for the public, make sure that you grab one of these folders and follow their project on the QR code. If you were inspired by this and want to join the next 1 month hackathon, it starts in September and we have a kickoff live on YouTube and live in June.